Apple is releasing their new device, the Vision Pro, this week. Some people are very optimistic and excited about this. Some other people are calling it a very bad news. But beyond the device itself, it stirs up an ongoing conversation about virtual reality and augmented reality. So let's talk about it together and start with some of the basic concepts. You have a definition of reality that often leaves me with more questions than answers. You say that reality is something that is shared and therefore objective. By opposition, a subjective experience therefore wouldn't be real. However, religions or football game rules or even money are all shared by those who believe in them. But does that make them really real? Yet, is the pain and suffering of one individual a fully subjective experience in itself, not real? Can you try to define the term augmented reality and explain why you said in a previous blog post that you think these two words are often misused?
So augmented reality refers to technology where you overlay some digital information on top of the physical world. So many people may have experienced that with some fun little AR game or something like this, where you can see an AR creature in the real world. This is different from virtual reality, where you are transported entirely into a digital world and you're made to feel like you're really there. So augmented reality is when we bring digital things into the physical world, and virtual reality is when our physical body goes into the digital world. I have argued before, though, that the term augmented reality is a bit of a misnomer. It was a term that is only now starting to actually exist. And what I mean by that is, I think core to the human experience of what is reality are the things that we can perceive together. If you see something unusual, your first reaction is going to be, did you see that too? There's something deeply jarring about knowing we have a perception that is very different from how other people perceive things. We notice this even in small innocent examples, like if you're the only person that did not laugh at a joke, that really doesn't feel good. It even doesn't feel good to be the only person to laugh at a joke, because there's subconsciously then we understand that we did not have an intersubjective experience with other people. When I talk about what makes something a reality, the focus is not on what is objectively true as much as what is intersubjectively true. I believe that you can think of the human being as having a kind of truth-finding algorithm that operates at the level of our senses. Like if you try to watch a video and you make the audio be delayed compared to the video, that will feel really unsettling. And the reason why is because you don't have sensory congruence, meaning your different sensor experiences don't match with each other. And we are evolutionarily programmed to want sensory congruence. Whenever there is incongruence with our sensors, we can quite literally feel sick. Like this is what motion sickness is. One of the things that really plague people experimenting with VR is that they can end up feeling physically sick because their eyes are telling them that they're moving, but their body is telling them that they're not. We need sensory congruence. And my claim is that this need for sensory congruence is so deep in us that it even extends to a social component. It's not enough for us to want our eyes to agree with our ears. We also want our ears to agree with the ears of other people. Did you hear that? Is a deep existential question, actually. It's us questioning our sanity in a way. So when I said, especially in 2021 when I was beating this drum a lot, that augmented reality is a misnomer. What I meant is if the experience can't be shared, which is one of the great technical challenges of AR, if we can't see the same thing in the same place, we're not going to experience it as reality. We're not really augmenting reality. Reality is the intersubjective layer. We kind of know it in our bones that that's what reality means.
What is Apple trying to do then by calling their new device a spatial computer as opposed to an XR headset? And can you define spatial computing in simple words?
There's a big controversy in the XR community now about Apple choosing to call their new device, the Apple Vision Pro, a spatial computer rather than an XR headset. People that are not fans feel like Apple is trying to reinvent an already existing market. But I actually think there's something quite clever going on. By calling it a spatial computer rather than an XR headset, the emphasis becomes on the fact that it's a computer that's spatial rather than it being a headset. So the form factor is not the most important thing of the Vision Pro. It's what it does that's the most important thing. Spatial computing is the art of teaching digital devices like computers to understand the physical world and their place in it. And when Apple says that the Vision Pro is a spatial computer, what they mean is this is a computer that understands your physical environment, and because of that, it can do tasks that your normal computer cannot do. So I'm actually quite in support of Apple calling it a spatial computer. Also because I believe that augmented reality is not a good term for these single user experiences. I am more comfortable talking about spatial computing than augmented reality because I think augmented reality is still something that we're aspiring to as an industry and we haven't really gotten there yet. But spatial computing, that has arrived.
So I understand that you mean that headset is not the end of the line for spatial computing. There's going to be headset, but there's probably going to be other devices that we don't know yet. Well, is there any other device that you can think of that can be considered a spatial computing today or will be tomorrow?
Personal computer brought the power of computers into everyone's home. The mobile computer made it possible for computers to come with us into all kinds of context. Spatial computers, the big change is that spatial computers understand the physical world. That's the big era transition. We're not entering the era of headsets, we're entering the era of computers that understand the world. And there are already companies building AR contact lenses, and just this week, Elon Musk's Neuralink just did their first human installation. So it's quite possible that 20 years from now, the headset era is already gone, but we will still be in the spatial computing era.
Right.
The big transition that is happening, that is on the scale of the invention of the computer or the invention of the internet, the invention of spatial computing really marks a very important milestone in the history of human civilization, whereas the headset is really just a temporary form factor for this type of computing.
So what's interesting probably about the headset is that it's a self-contained device that has all the sensors it needs to understand the world around it. But let's assume there's another computer, a spatial computer like a phone, who doesn't have all the devices, all the sensors, but can utilize what other devices in our room, in our world, collects. For example, a camera could be set up on the ceiling in a room. I remember we talked once about those little iRobot vacuum cleaner who just roam around your room. They are not spatial computers, but they're spatial data collecting devices, which can then in turn communicate those to our spatial computer, which again could be a headset or something else. How do all these devices communicate together and to the spatial computer? Which language do they use to communicate that, and how does the computer process all those data so far today?
For a spatial computer to understand the physical world, it needs sensor input. It needs to be able to look at the world or listen to the world. It needs some kind of sensory experience. In fact, Lili Chung, vice president at Microsoft, once said that mixed reality is the eyes and ears of AI. It's interesting to think about. If we want AI to understand the physical world, it needs some kind of perception, actually, of the world. And the Vision Pro, as a spatial computer, comes with a bunch of sensors built in. It has motion sensors, cameras, LiDAR, things like this, that your modern smartphone also has. Your modern smartphone is also a part-time spatial computer. But one of the big challenges of spatial computing is that it's very resource intensive. Like, it uses up a lot of battery. That's why the headset is very, very big. It uses up a lot of compute power. It's also why it's very, very big. And it needs a lot of different sensors. And one of the paths that spatial computing will evolve moving forward is to make spatial computing more collaborative, where the spatial computer or the AI trying to do spatial computing can borrow sensor data and spatial understanding from other devices. You don't have to imagine that the spatial computing software lives on a single device. It can be distributed across many devices, collaboratively creating a shared understanding of the world. The fundamental challenge in doing this, the thing that makes collaborative spatial computing so difficult, is you need to have a shared language to describe space, and the prerequisite for that is to have a shared coordinate system. I can't talk to you about what I'm seeing unless I can tell you where I'm seeing it. As humans, this is not a very intuitive problem to have, because we have a sense of proprioception, we have a sense of where we are. You know quite well that I'm sitting in front of you, etc. But computers don't have this understanding inherently, and they don't have a mutual coordinate system that they can use to communicate. Now you might think like, oh, don't they have the GPS and things like this? Sure, but a GPS cannot place us in this phone booth. It cannot place us on the floor of this building. It can barely place us in this building. And if we want to be able to collaborate and say, the chair in front of me, we need to have a much better understanding of where we are relative to each other. So one of the core problems of spatial computing is how can you allow a computer not just to understand its physical space, but to describe the physical space in a coordinate system that is intelligible to another device? How do you arrive at a shared frame of reference? And this is core to what it is we're trying to do with the posemesh, to establish the foundational language and methods for arriving at shared communication about space. We need to be able to get into the same coordinate system. We need to be able to describe our observations. We need to be able to do all of these things in a mutually understandable, interoperable language that all devices can participate in. The benefit of being able to do that, like if you build a decentralized collaborative spatial computing platform, the benefit is that then AI and spatial computers can very easily borrow sensor data and spatial understanding from other devices and can solve more complex tasks that way. But also the sensors, the headsets, the things that move around in the world can make use of less battery and less compute, because you can put a lot of the compute tasks and storage tasks, etc., on stationary computers that are plugged into the wall. So we believe very strongly that the path of going from a big Vision Pro to some very small Vision Airs, if you will involve doing collaborative spatial computing, where a lot of the spatial computing work doesn't actually happen on the glasses themselves. It happens in a collaborative network of computers, ideally one that you own and control inside your own home. But other big spatial computing companies, Microsoft, Google, etc., they see their cloud being a big part of this, and that we will be collaborating over their cloud. The scary part of that is that they, as a central provider, then get access to so much of what it is we see through our sensors, and it creates a very, very pernicious opportunity for surveillance. So the most popular approach to positioning in the world right now, for practical reasons, is positioning based on the camera feed. The idea is that you compare the camera feed to an existing model of what the world looks like. If we create a 3D model of this space, then we can compare your visual feed to that model and calculate, based on what you can see, where in the scene that you are. And those kinds of algorithms work very well, actually. The problem is that the digital copy of the world is much too big to live on the device, right? Much, much, much too big. It can, well, it's huge, really. So,
like, do you have a number?
So a typical spatial anchor for one of these major cloud providers, which will cover a small area, like maybe just this phone booth, could be somewhere between 20 to 200 megabytes big. So now if you're imagining you're gonna map out a whole public library or something like this, you're dealing with gigabytes of data, and that's still just one space. Now imagine that you're gonna deal with your local city, and it's now more space than can conceivably fit on your device.
This data is made of what exactly? Pixels, informations, what is it? What's in there?
It's a 3D reconstruction of the world. So yeah, it's pixel data, it's geometry data, it's a 3D representation of the world, like a 3D game map,
so
right?
Can we assume that as our devices capturing abilities increase, the size of these will also increase?
Yes, the higher resolution you want to capture the world in, the more space it requires. However, with the posemesh, we've taken a very different approach, where we try to semantically compress the model to only keep a very simple spatio-semantic representation of the world. So spatio-semantic, so let's start with, what does semantic mean? Semantic means meaning, literally. The semantic context of this is that it's a flower. And when a computer vision algorithm does semantic segmentation, what it means is it understands what part of the picture has what meaning. So semantic segmentation is able to, for example, pick out the flowers from an image. Semantic compression is when we take a complex 3D model, we understand its semantics, and then we represent that object in a much simpler way. So we could imagine these flowers, for example, being represented by thousands, tens of thousands, hundreds of thousands of individual polygons, and that's a lot of data. But we could also just compress it down to a circle, or a sphere, and say this sphere is flowers, there's flowers here. Then we've done a spatial semantic compression. There's a description of the space and its semantics. So a spatial semantic representation of a space can be much smaller than a full 3D rendering representation of a space. Many, many orders of magnitude less. The spatial semantic representation of the Hong Kong FinTech Week, this big conference that we provided navigation for back in October, November, that was 17,000 square meters of conference represented by 250 kilobytes of data. So a fraction even of one spatial anchor, and it would have taken perhaps hundreds of spatial anchors to map out that whole conference.
And by doing so, you don't compromise on precision, on accuracy, you don't...
Absolutely you do. There's always a compromise and a trade-off for everything. But the trade-off of having the high rendering thing is that it's too much data to conceivably put into the device. So we're making different trade-offs. We're making it possible to get 80% of the value of understanding the scene around you, and make it possible to collaborate around it, even when there's limited bandwidth, limited internet, limited computation, limited storage. So we're choosing a different set of trade-offs. The benefit of having a very rich digital twin is that you can faithfully recreate it, but the drawback is you cannot have it realistically on your own device, and it's much too large to collaborate on, etc. So we're choosing a different set of trade-offs.
So we've defined well enough, I think, the concept of spatial computing. How is AI playing a role in the development of spatial computing? And are those two words, spatial AI and spatial computing, interchangeable?
So AI and spatial computing have a two-way relationship where a lot of the computer's ability to understand the sensor data is machine learning and artificial intelligence, but also if you want an AI to be able to understand the physical world, it also needs to be using spatial computing and spatial data. So there's a circular relationship here where advancements in AI lead to advancements in spatial computing, and advancements in spatial computing lead to advancements in AI. So anyone that is interested in AI, especially in the long-term impacts of AI and trying to predict which AI companies are going to come out on top, need to have an understanding that spatial computing is an absolutely essential part for artificial intelligence to be able to understand and operate in the physical world. And that a collaborative approach to spatial computing allows for more complex, distributed spatial computers to be assembled.
So it's a symbiotic relationship between AI and spatial computer.
Yeah. The advancements in AI lead to advancements in spatial computing, and advancements in spatial computing lead to advancements in AI. This is a positive feedback loop that has only been accelerating over the last few years. Apple is really trying to teach us that the big shift that is happening now is that computers are starting to understand space. They call the Vision Pro a spatial computer because it's a computer that understands space. They don't call it an XR headset because that's drawing attention to the wrong thing. The form factor of it being a headset is not the important part. The fact that it understands space is the important part. And the fact that it's a computer, not a gaming console or something. It's meant to increasingly replace the tasks that you perform on your mobile computer and your desktop computer. As an industry, I think we should be thankful actually that Apple is helping focus the attention on the utility of this technology rather than the form factor. The utility is computers that understand space. That's what it does. The form factor is just headset, but that's probably not a permanent state of affairs. There are already companies building AR contact lenses. There are already people building neural interfaces. Eventually, even the headset form factor will be gone, but we will still be in the era of spatial computing. And this, I think, is important for founders, for developers, for investors to understand that the transition to spatial computing is an event in human history comparable to the invention of the computer, comparable to the invention of the internet. And from this decade forward, we are clearly in the age of spatial computing. I'm not saying that Apple invented the spatial computer. Of course not. Spatial computing as a term has been around since at least 1993. But arguably, the understanding of where we're going with spatial computing under other names, other terms, already in the 80s and even in the 70s, visionary thinkers understood where this technology is headed. People like Terence McKenna understood where this technology is headed. It will have the whole world as its context and not just the internet as context. Because of this, 7 out of 10 of the world's most valuable companies in the world by market cap are heavily invested in spatial computing. Spatial computing literally holds the key to the future of robotics, the future of the metaverse, the future of IoT, the future of AI. And it's important for us to be aware of this technological advancement. It's important to understand the implications of this technology falling into the hands of centralized organizations. And I think it's important also for the decentralization movement to understand that spatial computing is one of the battlefronts where decentralization can yield the best outcomes for civilization.
Auki Labs. Share your vision.